Control, close it. Online team, you can see my screen, isn't it? Yes. Okay, good. Shall we start? Excuse me, you're new? Online batch. My batch? Which? Durga Prasad, okay. Okay, so let's start today's sessions, all right? So I hope we continue this one, which is called multiple linear regressions. In multiple linear, what would be the independent variables? How many, guys? It's more than one, isn't it? In more than one. So just put it with Notepad plus. Just one moment. I'll show, guys. Last week, another students got the offer. My student, I'll show you. Every week you get 1 or 2 students, trust me. Okay, so did you see this? Let's start. Getting the same one. Okay, nice. All right, so NumPy, Pandas, Matplotlib, it's quite common, yes, everyone. And this is the data set which we imported. Let me repeat again. And as you know, we have around what would be the dependent variables, profit, and rest of 3 are independent variable, right? So if I say x1, x2, x3, x4, and y, isn't it? So the constant is missing over here. So I just wanted to add the constant later part. So x independent variable, let me execute. So this would be the independent and this would be the dependent variable. Yes, I hope we know this one. So this is what we understood last week. Oops, why few people not joined yet? Good morning. Should I share the link today, class? Excuse me, team. I don't have link today because I am logging from my app. So why the problem happening with you only? So why don't? So online team, anybody, do you have any process to, do you have any process to connect? Do you have any process to connect to the, I mean, online Abhishek? I mean, how do you got the links? Because these people are quite confusing because every day they just check in for the links. So any process, could you please step it down and put in the chart window so that everybody can figure out? Yeah. Can you do that, anybody, please? Excuse me, team. I don't have a link today because I'm logging from my app. Why the problem happening with few students always? Please fix it. Yeah, Jay, just write down the steps, step 1, step 2. All right, Washim, and just put it in the, there is some problem while trying to log in, the website is not opening on laptop. So why don't you try some other browser, Uday? Maybe you can try from some other browser, isn't it? Okay. All right, so let me post. Okay, so let's see today's sessions. Yes, they do provide login details, correct. You need to log in the online app. Okay, let's come back to the work. So I split the data set into independent and dependent variable. Yes, and which categorical variable available we have in state, which is independent variable, right? Which have independent variable. Now what I do, y x equals to dummy. Yeah, dummy means what? I just impute all these variables so that I can make it to the I mean, California for one and New York for one and all those things, isn't it? Now the next step is train test split. So let me execute this one. Let me execute. So why feature scaling is not required? Why feature scaling is not required? Because regressions. Now let me tell you, there are few algorithms does not require feature scaling. For example, regressions and tree algorithms. What is meant by tree? So this is called decision tree and random forest. All right. These algorithms does not require feature scaling. Remember this. All right. This is must you need to understand, because when I talk about entire regressions part, it does not require any feature scaling, but for the rest of algorithms like KNN and all those things, naive Bayes, logistic, we required feature scaling. True. Now here we go. As this is the regressions algorithms, I just split the data, and Friday I was talk about what is the process to split the data, what is 20%, what is 25%, and all those things. So let's do it again. Yeah, so I think, oops, yep, done. So here, out of 50 records, I take training as 40 records and testing as 10 records, isn't it? So train as 40 and test as 10, as you know this. And multiple linear regressions also, it is a linear regressions, isn't it? So for this multiple, there is no other packages. Simple, multiple, both comes under from sklearn.linear model, isn't it? So when I say sklearn.linear model, so we have SLR and MLR, both comes under from this packages, right? Let me execute this one. And regressions, I create a variable called linear regressions, and I fit the model. What is the model name? Regression is my model name, and we fit the model, right? And let's predict the X test, and I compare with Y test and Y pred. So the one who is missing on Friday sessions, I want you to go for recording and understand. All right. So here we build Y pred. Yes. So last week I talked about what's meant by starts model.formula API team. What's meant by this? It is just API connections between statistics to machine learning model, isn't it? So this is an agent, means what, guys? API is nothing but they take informations from the stats and give informations to the machine learning. Understand? So let's do this. And at this moment, we missing constant. What is the equation? Y equal to m1x1 m2x2 plus c, isn't it? So c means constant. I mean, intercept is missing over here. So I wanted to add the values 50,1 for everywhere. So let's do this. And if you check this out, which one, which part? X is 1. Yeah, x. Did you see constant is added or not, guys? Yeah. Now, till this part, the model is built, guys. Till this part, the model is already built over here. But what we're doing, because the CEO gave some use case, which attribute you need to invest more money, isn't it? Online team, are you understand or not? Yes, guys. Which attribute you need to invest so that to get a more profit, isn't it? So he don't want to, due to COVID situations, the business startup company does not want to spend more money on multiple domains, right? So that's what the business use case. And we trying to do, and last, I mean, we add this, the finally import stats model SM X opt independent variable. 0 means what, guys? Let me open this. Just 0 means constant. 1 means admins R&D, I think. R&D or admin, guys. Just one moment. It's R&D, yeah. And 2 means admin, and 3 means marketing, and rest of them are dummy variable, isn't it? Now, sm.ols, because these are the parameters which we saw where in starts model.api, isn't it? And finally, I'm saying build the summary table, which we called regressions table, And this is what we built for last time, isn't it? Just one sec. Let's take more time. Yeah. So this is the table we built. For the first time, when I build, what exactly I need to check? Let me write down. In multiple linear regressions, once we build MLR, okay. Once, yeah. Once we build MLR model, we will generate regressions OLS table, right? So first thing, what you need to check is the first one, does R square is greater than adjusted R square? This is the first point, understand? Second point, what do you need to check? No, you need to check, does these values are range between 0 to 1, understand? The third one, you need to check if the p-value, because what is significance value? Significance value, let me tell you, when you write an exam, what would be the 60% first grade, right? The significant is what? 60%. Agree or not? Yeah. The same way in statisticians take the significance level as 0.005, isn't it? Understand? These are the steps you need to check. And the fourth one, 0.05, I'm sorry. Yeah, 0.05. Yeah. So if the p-value is greater than 0.05, what you need to do, guys? You need to reject the null hypothesis. We called in statistics terms hypothesis, but in this is called stats. But in ML, we eliminate the feature. Feature means what? Attribute. If we eliminate the attribute, the fifth one, keep doing the steps. Okay, keep doing the steps till check the condition p-value does not greater than, p-value less than or greater than. Just one moment. Let me check this out. Yeah, p-value greater than, right? So this is 9. No, p-value is less than, I'm sorry. P-value is less than, isn't it? Sorry. So it will keep doing these steps until the p-value is less than or equal to 0.05. Okay. And then finally we build the model, and that would be that attribute, whatever the attribute is left, right? Whatever the attribute is left, that would be our answer. That would be our attribute, which CEO or business company, business need to invest money on those attributes. So being a data scientist, all these things, you have two suggestions to the company folks. Understand? Yes, Chandrahas, understand or not? So now here, let's do this. Online team, correct, Jayed. Avinav, Yasin, you there today? Yasin, are you there today? Okay. Good. Yep. So if you see this, check one by one conditions. R square is greater than adjusted R squares. Perfect. Yeah. And then what else? Then we need to check. Then we need to check what exactly, guys. All both are 0 to 1. The range is 0 to 1. Okay. What is the good model? Always the good model lies between 0.06 to 0.9. Understand this. Okay, guys. The next one is the p-value. Which one is the highest value? X4. X4 means 0.990. So why we not take opt means 0 to 6. You can take Abhishek. You can take. Actually, that should be 6. Should wind up for 5. You can take everybody. Take 1.6 and you can do it. This is for your home task. I just assigned. Yes, Abhinav? Yeah. So now 0.990 is the highest, I mean, 0.990 is greater than 0.05, isn't it? So what we need to do, you eliminate this one, 0, 1, 2, 3, 4. So the second time, what I do, the fourth I eliminate, isn't it? The fourth I eliminate. So when can we do this? At this moment, the R squared is 0.95 and adjusted R squared is 0.94. Agree? Now, when I do it again, so what you found? So you got as 95146 different R squared or not? Because the coefficients are changes. When the coefficients are changes, you will get different score, isn't it? So in this case, 0.95 is greater than 94. Now, one eliminate is removed. What exactly the next highest p-value? Which one is the highest p-value? X4. X4 means which index we have, Avinav? Yasin, which index we have? 4, fifth one, isn't it? 5, isn't it, guys? Because here, if you see X4, X5, so 3, I mean 0, 1, 2, 3, 4, 5. So 4 I've been eliminated before. Now I'm going to eliminate 5. Yeah. So let's build the model. I keep repeating the steps until your voice is breaking. Is it for everyone? Is it for everyone? No. No, Yasin said no. Check. Okay, just let me know once you get it again, okay? So in this one, let's do it. Let me do the next step. So what exactly happened, guys, here? So did you check 3, 4 we eliminated, 2 attributes we eliminated, means dummy variable we eliminated, isn't it? Yes or not, guys? We eliminated the dummy variable. Now we eliminated the dummy variable. Pratyush, I hope you understand. Avilasha. So here 0, 1, 2, 3. Do you see any more values which is greater than 0.05? Yes or not? Which one? 0, 1, x2 means give the indexing 0, 1, 2. So 2. So index 2 again 0, 1, 2, 3. I remove the 2 and I keep repeating the same steps, isn't it? So let's do this again. And I found, check this, 9550, 948. Good model again. And then ranges are 0 to 1, correct? And let's check. Let's check. Do you have anything else? Do you have anything else? 0.6 is also greater than 0.05, isn't it? So now which one? 0, 1, 2. So 0, 1, 3. So 1 is there, right? So let's eliminate the 1 and let's do this. So now is there any values which is there any value which is, now see this? There's no p-value. Tima, you understand? So does this 6 points is connected with your regressions or not? Agree? Agree or not, everyone? So tell me, if I talk about the data set, yeah, this is the data set. Now, what you need to suggest to the business guys? Company need to invest on which attributes? Which attributes, guys? R&D, research and developer. I hope you're clear, guys. So this is called multiple linear regressions. And anybody's completed this? You done? Okay, good. So now online team, does anybody's completed today? I mean, you start today. Okay. And before that, I want you to give some task. Let's do this. Just bear with me. Okay, see this, guys. So this is what I think everybody's completed. If not is done, just ignore. Okay. As machine learning is started, ignore the one who is not done yet. Understood? Please continue everything one by one, because I am not explaining such a very hard topics. Yeah. So I'm explaining very lowly. So this is what we done. classwork data pre-processing, Titanic process, one concepts, one code, one task. Good enough. All right. One concepts, I explain the concepts, I explain one simple work, I one task. Same way for this one, house price predictions, we used how many variables? Which task you're working? Sample completed? Okay. So now, in simple linear regressions, we considered only one attribute, one independent and one dependent. So, but not post, no problem, Avinav, not required. Yeah. Every time I see where the status is all about, yeah, no worries. Yeah. So in this multiple linear regressions, I explain the same steps. You need to implement the same steps. Do not go by the code, whatever they mentioned. Sadiq, it was interesting. You built yesterday. Yeah. Yeah. Good. Now, so this is called same things we've been done, same data set, as you know, multiple linear regressions. In this one, print categorical data and you need to data set, drop ID and date because this is irrelevant attribute to plot, understand the distributions with seaborn. If you understand, well and good. If not, also remove this one. This code you can remove. But if you have, that's okay. Separating dependent, independent variable, X and Y, correct? Split the data into training and testing phase. Now build simple linear regressions model right now. Now the next step is, if you see the backward eliminations, okay? Now, if you see this code, what happened? We did the back eliminations step by step, right? So if you guys are a little bit good at coding, you can follow this code, but I want everybody to don't do with this code. Same step, whatever I mentioned over here, these indexes, follow the same, let continue the process for 20 steps, right? No need to worry. And you can find out the attributes. This is what the table they build or not. Yes. When you do independent attribute, these attributes are highly essentials to build the model. You cannot eliminate these features, guys. Look at this. What is a 0.000? This one you can remove, right? And that's it. That's it. I hope you understand, guys. Can you do this, everyone, today? Can you do this? And everyone need to do with this one only. And just post only one line of code, not this one, this part. Only one code and maximum one or two with output. Then your concept is clear. MLR is clear. All things is clear, guys. Now, understood or not, everyone? Yes, guys. See, guys, this project would help you to survive the job. You know why I'm saying? Because yesterday, Saturday, my one of student, his name is Miraz Ali. So he completed 3 months ago the course. All right, 3 months ago. But still he skipped connections because they have any questions, they ping me. So I just definitely I'll help them out. Just one moment. It's okay. So let's do it. In the meantime, let's go back to the work. I hope you're clear. So this project list I will share today. Now the next one, what I'm going to explain you today is polynomial regressions. What exactly this one? Polynomial regressions. 16th, today 16th, polynomial regressions. Understand? Now, so far, just one second. So far, okay, regressions has one sec. There's two types of regressions we have, guys. One is linear and one is non-linear. Remember this one. What is this? One is linear and one is non-linear. Now, simple questions. Which algorithms come under linear? Simple linear regressions. Means what? Am I getting the best fit line? Is it a linear or not? Listen to me, everyone. Is it a linear or non-linear? It is a linear, right? Now, let's close this. Another one we called, no, I'm sorry, multiple linear. Multiple linear regressions. Understand? The second one is called, because why MLR is a linear? Because we mentioned, did you see this model? Which one we called? We called a simple model, linear model, isn't it? Check this out. A sklearn linear model, isn't it? When I say clearly linear means it is a linear only. The third one is called gradient descent. Okay. There is no practical required for gradient descent, but still I will give you some practical. Understood? I'll give no practical, and also we called as stochastic gradient descent. And also, I mean, descent has many types. One is called batch gradient descent. And this is short interview questions, team. Understand? And I'm explaining very slowly so that you understand and you can clear your, clarify the rounds. Understand? So this one, how many algorithms we have under linear? Simple, multiple, and gradient descent, isn't it? Now the next one, what is nonlinear? Under nonlinear, we have polynomial regressions. The second, support vector regressions. The third, decision tree regressions. The fourth, random forest regression or regressor, anything called as. The fifth one, regularizations, and again regularizations come under, we called as lasso regularizations, or we also called as lasso regressor, also we called as L1. All right, L1 regularizations, right? And the sixth one we called ridge regressions or regularizations, and ridge regressor, and L2 regularizations. Understand? If we complete linear and nonlinear, okay, we complete the regressions part. Then we go for to the classifications. Clear? Clear, guys? Actually, decision tree is a classification only. Random forest is classifications only. But I will tell you why we sometimes use the package for regressions as well. Understand? So this gradient descent, I will give you a concepts very slowly. This gradient descent would help you on neural network. Where is it? Neural network. So GD means what? Gradient descent would help you a lot in neural network. Understand, guys? So real sessions, your resume preparations, project sessions starts from last week only. The moment when I start machine learning, all those things is started. Yes, guys? Okay. I hope you understand. See this, guys, this one, he mentioned, hi sir, how are you? Saturday at 12:31, a company whose name is Brightpoint AI Technology, Chennai based. He offered me for a machine learning engineer role, package offer 5.5. After 6 months based, the performance, it will increase the salary. This is a product-based company. What is meant by product-based company, guys? They have own products, isn't it? Which never end. For example, if you get a job in MRF, So your job is secure. It's kind of government job, isn't it? So every week I'm showing you one offers. I mean, I hope you understand, guys. So there is some, definitely whatever I'm explaining, it works because I'm working professionals. I know, guys. Understand? So finally, I said, finally, hard work pays off. So maybe he will receive his offer today and tomorrow I will share once you get it. All right. Clear online team, understand or not? Yes, guys. So now let's get back to the work. So multiple we completed. Let's start gradient descent. I will explain tomorrow. I mean, not tomorrow if possible, but let's continue with the nonlinear algorithms, which is called polynomial regressions. Now, listen to me very carefully. Listen to me very carefully. Do you remember in school days, we know uni means one, bi means two, poly means what? Many. Understand? Poly means many. So here, x-axis and y-axis. This is best fit line. This is best fit line. One moment. It's a linear or non-linear? What is the equations formula? mx plus c. What is the x to the power over here? X to the power is 1. So if I take mx to the power 0, what happened? This line becomes like this. Agree? Agree or not? So linear algebra I'm explaining, guys, to you now. Linear, right? Now, when I say clear this one, let me close it, okay? And let me draw it again. So in this line, x to the power 0, understand? This best fit line, x to the power, when I say x to the power 2, what happened this line? Little bit curve, linear or non-linear? That's why we called as non-linear regressions. Understand or not, everybody? Now x to the power q, what happened? More curve. X to the power 4, what happened? Again, more curve. This concept is called polynomial regressions. Means every independent variable, the degrees if I change, that becomes the polynomial regressions. Understand? We never use this algorithms in real time. But why we learn? In future, I will tell you parameters as poly is one of the parameter. If you understand, then SVR you can understand. It is connections to the other algorithms, guys. Understand or not? Yeah. So let's close this. What's a company required experience, man in ML? Which company said, Avinav, like that? These students doesn't have experience. Whoever got offers, right, Avinav? So that's what I'm saying. In 3 months, I will make you 3 years of experience. Understand? Okay, don't think too much. Just continue. Make resumes, upload, keep giving interview, flunk 20 times. Yes, sir, but few companies. Forget about those companies, man. Right? Okay. Let's go back to the work. Let's go back to the work. So here, let's close this. Yeah, polynomial regressions. Let's do this. Okay. In this case, what happened, guys? Let me show you. 0 degree poly. What I get? Constant. Y equal to constant. 1 degree poly. Y equal to mx plus c, isn't it? 2 degree poly. Y equal to x square plus bx plus c. Can I fit into these equations or not? Yes, guys. Yes, nth degree. You can nth degree, but how do you check this in our data? So that's very important. Okay. So here, so this one y equal to alpha 0 and alpha 1 x1 x squared x3. Can I say that alpha I xi? Yes, I can say that. Plus polynomial functions. This is all about the polynomial regressions, guys. So if you see this, simple linear regressions, B0 plus B1 X1, multiple X1, X2, X3, polynomial X1, X1 square, X1 Q, and here goes on. Understand? Understand, guys? Now directly, let's build the model directly. Okay, there is no such concepts. This is simple concepts, understand? I mean, I explained you. Let's get back to the work now. So at this moment, I have one data set. Okay, this is the data set. For the same data set, okay, for the same data set, I build polynomial regressions model. I will get some accuracy. For the same data set, I build SVR model. For the same data set, I will build decision tree regressions. For the same data set, I build random forest regressions and KNN. All these algorithms are linear or non-linear. Linear or non-linear. Non-linear. Same data set, KNN gives some accuracy. Polynomial gives some accuracy. SVR gives some accuracy. Decision tree gives some accuracy. RFR gives some accuracy. Okay. Whatever the highest accuracy, let's go and deploy the model. Okay. What is meant by deployment? Is same accuracy. You never get. If I give you a food meal, do you think the meal is same test for all the hotels? Avinav? No. Somewhere it is different, isn't it? The behavior of is different, isn't it, guys? Please understand. Okay. Now, understood. So first, we understand the polynomial deployment part. I will explain later after complete all classifications algo. I will talk about deployment. There are very important topic of deployment is available. I will explain you later part. But at this moment, this is the beginning level. We try to understand all the concepts, basics, all these things. So now I will create some of the business scenario strategy by look at this data. So if in a company, these are the positions: business analyst, junior consultant, senior consultant, manager, country manager, region manager, partner, senior partner, C-level, and CEO. Okay. Business analyst number is 1, junior consultant number is 2, and his salary is 45. Not the means level. Understood, guys? So business, many people are there. So their level is 1 and this package is 45K. Senior consultant and all those things. In this, as the data is very less, we not going to do train and test. See, guys, let me tell you, let me explain you one thing. GDU, yeah, classifications. So 99% ML algorithms we build model with train test split. Understand? Every time we build train test split, but let's build the model without train test split this time. Okay, so that you can hands on to both the cases. If someone asks you, can you build the model without train test split? You shouldn't say no. So at least we should understand those things as well. I'm not able to see other participant message. Rahil, is it really required for you? I can see it, right? First, you listen to me. That's good enough. Because the relationship between you and me. Okay, buddy? Yeah, Rahil? All right. So let's build without train test split. Let's build without, let's build without train test split. So the first one, I'll give some of the scenario here. The scenario is a company called ABC hired you as a data scientist, right? As a data scientist. So in this case, what exactly it is a HR requirement? What is HR requirement, guys? HR has a lot of manual work, isn't it? Manual work or not means, are you ready for interview? Once first round is done, second round is done, and payment regarding the salary part. So are you okay for 3 lakhs? Are you okay for 5 lakhs? All things discussion is there. So for one student, so they have many students, isn't it? So now what HR requirement is, she wanted to automate the process. She wanted to automate the process. What she wanted to automate, I cannot ask questions. Sunita, I don't understand. What's your questions? Okay. Just you can post your questions you have. I can check it to your questions. All right, Sunita. Yeah. So HR requirement, she wanted to automate the process, but I thought message is not sent to you. No. I'm see the screen. You can post your questions, everyone, if you have. All right. So now what exactly HR do? So let's say this is the file shared to the data scientist. This is the file shared to the data scientist. Now, what her requirement is, what the HR requirement is. Let's say in the company called ABC, if the positions, business analyst positions, the level of salary is 45,000, right? So tomorrow, if an employee, okay, whose level, whose experience, I mean, level of experience is 1, 2, 3. If they come more than this, what exactly package they will give? Let's say, what is the level of experience, guys, here? 6, right? So if the level of experience is 6.5, he will come to the organizations for an interview. So what exactly package we should give them up? So the most negotiations part is salary negotiations between employee and HR. So what she wanted to do, she needs to create an app. She wanted to create an app. Okay. In the app, name, age, gender, level of experience, company, actual salary. If the employer, what exactly HR requirement? She wanted to create an app, and this app has installed in the kiosk. Kiosk means what, guys? If you have company office gates, so the kiosk machines is installed over here, right? So when an employee come back to the office, before he entered to the office, when he entered all these informations, when he entered 6.5, so here one options will come, my company will pay you 180, I mean 1,80,000 for your previous experience by considered your experience. Understand? So now if the employee is happy, then he is get into the company. There is no discussions, give interview, offer is released. The time is safe or not? Understand, guys? Time is safe or time is not safe? Yeah. So if the employee is not satisfied with the salary, the backlog file will generate. What is the backlog? When the employee enter these informations, one Excel sheets goes to the HR and HR will get back to the candidate. I hope you understand, guys. So don't you think so? The manual process is down here. Don't you think the manual process is down here? So let's say in the kiosk, there is a queue. There is a queue. If the person is getting a little bit, I mean, talented guy, if you don't like it, you just get up, get back off. Yeah. But for others, definitely there is no salary discussions. The job is, the 2 interviews done and you see the results, right? HR will talk to you. Are you okay with your salary? I'm going to release the offer of this amount. And he take this screenshot and send it to him. Understood or not, guys? Understood? So what exactly happened here? Let me draw an architectures over this one. So this one, this is called app. This is called app. The back end is polynomial regressions model and the front end is app, isn't it? So here the Flask is over here. When a employee entered the data, okay, The data has take from this model. Model is fetching and give the informations to the app guy. So this is Flask, this is app, this is model, ML model. Now, don't you think entire process is optimized? Don't you think the process is optimized? The admin cost also reduce. Admin cost means what, guys? If people go on over there, they have to wait, they have to drink some food and all those things. Yeah. I mean, even the small things is matters a lot, isn't it? Yes, Archana, I hope you understand. Yes, Sunil. I mean, Sunita. So this is what, but at this moment, we don't create any app. So we just try to build the model building first. Then when comes to the app, that's not your job. Company has many people there, guys. So HTML, deployment, page design, teams are there or not? HTML, page design, all of them are there. Yeah. So I hope you understand. So let's build the model at this, in this data set, which is irrelevant. So in a school days, your teachers or your ma'am call you by as a roll number or name, roll number, isn't it? So same way, when I mentioned one, I doesn't require, guys, business analyst. So can I hide this or not? I mean, can I remove this? No problem, isn't it, guys? So when I say business analyst, the level is 1. When I say junior consultant, the level is 2. When I say senior consultant, the level is 3, and keep goes on, isn't it? This is the CEO level. And today onwards, we are going to start the polynomial regressions algorithms. I hope you understand, guys. Clear up to this one? Everybody's clear? So let's get back to the work. Every time, once you build the model, you need to restart the kernel, guys. This is the main important. So sometimes what happened, I saw many students, they restart the kernel like this, and now run the work, run the again code. It's not restarting yet. Did you see the variable is not clean? Just wait, refresh variables, right? It's refreshing, just wait. Now done, isn't it? Clear or not? Now you can run for any other codes if you have to work, right? Now the next one. So here, let me paste the, path over here. I will give resume by, this is May, June end or June mid of the week. After classifications, let's discuss some of the resume, some of the projects, everything I'll discuss. All right, what projects you need to mention. And if you want, you can speak with me on one-on-one basis and we can discuss rest of things. All right, NumPy, Matplotlib, Pandas as minimum, right? And now let's do this. This is the data frame we have. So let me remove this part because business analyst position is 1. So it does not mandatory that the positions I can mention over here. Yeah. So this one x datasets.ilog 1:2 means what, guys? What is meant by 1:2? So this is 0th index, first index, second index. That means, so I don't want 2 means what? 2 minus 1, isn't it? So 2 means 2 minus 1. I mean, I remove this one and I remove this one. So only this part is stored. Agree? Agree or not? So that's why I mentioned here x independent variable. Now, what is the dependent variable? Straightforward. Let's remove this one from here. This could be the dependent variable. This could be the dependent variable. Understand? Now, from sklearn.linear model, you might ask a question. So for comparison, I'm going to build 2 model. Okay. This is linear and this is called non-linear. Okay. And we try to check the comparison, how exactly it looks like. So in this case, sklearn.linear model import linear regressions. Done this. Linreg linear regressions is the variable which hold these algorithms. Let me execute this one. And now linreg.fit x comma y, x comma y. The model is ready. Agree? Train test not required because the data has very less data, 10 data. Yeah. So that's why the train test is not required. All right. Now, clear or not this one? From sklearn.preprocessing import polynomial features. Understand? Now let's click this. And before I go for this one, let me copy and I am going to paste here. So every time I'm talk about these parameters, this is very important on your interview sessions as well. Yes. Degree equals to 2 means what? Power is 2. Okay, everyone. Yes, Yasin. Oh, team, are you understand? Are you understand? Online guys. Wasim, Uday, Jaid, Ajad, Shiva, Rohan, Ramya, Pratyush, Nischit, Mohammed, Arshad, Kaushik, Drakshayani, Chandramali, everyone guys. Ashok. Okay, yeah. So intersections is only false, include bias true, order C. So this is system defined variable. So I don't want if you can delete. Okay. So sometimes you should understand which you don't understand. You should not attach to the variable guys. So at this moment, I will remove this. And when I do hyperparameter tune, I keep change these degrees. Understand or not? I keep change the degrees. So let's minimize and go to the variable explorer. Go to the variable explorer. I'm doing degree equal to 0. Okay. So because starts degree with I'm doing parameter hyperparameter tuning, guys. By default, how many degrees system suggesting to us? 2, right? But we're trying to change to 0. So because I just want to compare from 0 polynomial, x degree, 0 degree poly, 1 degree poly, 2 degree poly, 3 degree poly, right, Sunita? This is called hyperparameter tuning. So sklearn.preprocessing import polynomial features done. Now I said poly regressions equals to polynomial feature degree equals to 0. So let's do this. And x poly fit the polynomial regressions model to the independent variable. Clear or not? Now poly regressions dot fit. So 2 times I can use fit. No, you have to transform, then you fit the model, right? So this is linreg2 for linear regressions, and this also to fit the model. Yeah, 2 things is done. Now very simple, guys. Plot the scatter plot, copy image, and let's go for paint. What happened? Did you see linear regressions? What was the degree over here? What is the degree over here? X to the power 1. I am saying linear regressions. Okay. Did you check this one? Plot scatter XY color red. PLT dot plot X comma linreg. Linreg means what, guys? Linreg means this one, linear regressions. And linreg 2 means what? Polynomial. Did you check this one? Understand? So that's why these 2 packages are built. And linear regressions and all those things. For polynomial regressions, PLT scatter red, linreg2 dot predict. Yes, guys. I hope you understand this one. Now let's do this. Copy image and you're going to paste over here. See, this is y equal to mx1. Okay. This is y equal to mx0. Guys, are you understand or not? This is how many degrees? Is this a good model? Is this a good model? Now let's say, no, this is not a good model at all, isn't it? Now let's say to the company, let me close this. So if an employee come to the organizations for an interview, all right, so whose level of experience is 6.5. So in our company, We are paying $150 million. Understood? So if an employee come to the office 6.5, what should be the package, guys? What should be the package? Greater than 150 or less than 150? Online team. Greater than 150 or less than 150? Yes, greater than 150, isn't it? Everyone understand? See this. Now, let's say we try to build and compare linreg.predict 6.5. Check this one. What exactly we got? $330, man. So actually, we're giving 150, but my model predicted $330. Is it good predictions? HR will say, no, I don't want your data science jobs. See you, I can manage manually only, right? There's no automation is required, isn't it, guys? The same way, let's close this. Now in this one, linreg2.predict, this is polyrig.fit. Let me check how much polynomial regressions model predicts. 249. Again, it's a bad. Again, it is a bad. So what could be the next step we will do? What could be the next step we'll do, guys, on this scenario? Is it a good predictions? No. So in this data set, what is the next step, online team? We change the degrees. So tomorrow we'll change the degrees. Okay. So at this moment we done. Please work on the task and rest of things we can complete this, guys, tomorrow. Okay. And introduce to the gradient descent from tomorrow onwards. Clear? So installed higher versions. You can try, if check it out. And one more thing. See this, guys. Many times you're gonna get this type of error. So there's a 2 square boxes is there. When I remove one, okay, let's check this. You got expected 2D array. You got many of them, you got this type of error, isn't it? So how do you address this one? To add another square box here, you won't get these values, guys. Clear? I hope you understand, team. Done this. So actually salary for employee 6.5 is 150, but my model predicted 330 and how much this one, guys? 250 or 249? 249. Yeah, this is the wrong one. So tomorrow we keep increasing, we keep doing hyperparameter tuning, and we compare and we optimize which should be the good one. Understand? Clear, everyone? So please let me share. I think I already shared those things. Yeah, there's nothing to share. Tomorrow I'll share this polynomial and we'll complete rest of things. All right. Thank you so much, guys. We'll see you tomorrow. Have a great day. Yes, online team. Okay, bye, guys. Arshad, if you have higher versions, just try to check to the lower versions. It will work out. Yeah, it will work out. No problem. Okay. Sunita, understand? Yes, Abhishek. Durga Prasad, you stay. I'll speak and then rest of them will go. Okay. Yeah. Just prepare your, notes, guys, which should help you to clear the interview. That's very important. All right. And nowhere, I'm just giving this. That's okay. That's fine. But you cannot explain. You have own level of, your batting style is different than my batting style. Understand? So the same way you should know how to make yourself better to speak in front of the recruiter. Clear or not? Okay. I do see when HR call, people are scared. This is a first technical round. That's not a technical round. That's HR round. He will ask some projects. You will tell, I deploy all those things. Not required. They don't understand. Okay. So just listen what they're saying. I know when the interview comes, your heartbeat beats 200 per seconds. Take BP tablets or else you're going to die immediately over there. So what happened? Accenture just called and we got that. My kid is dead. Understand or not, guys? I saw many candidates like that. I said, just come. What happened? I said, calm down. Just calm down. Everything would be normal. Oh, thank you, sir. Then they come back. All right. Yeah. See you tomorrow. Have a good day. Bye. P value is less than 0.05, then we will eliminate. Sunita, what I'm saying, so 0.99 is greater than 0.05, right? Yes. I'm sorry. This is greater than. This is greater than. My bad. Yeah. Let me change it to greater. Okay, Sunita. Okay. Yeah. Let me put the notes over here. Okay. See you tomorrow. Have a good day. Bye. If you have regressors in both training and testing set. No, we don't predict X train. We predict X test because we build the model on X train and Y train, Archana. All right. So that's why we not do it. Okay. Yeah. And also just this is very simple code. No need for explanations. Just check this one. Plot the scatter plot between X train, Y train, red color. X train dot regressors dot predict X train color equal to blue. Understand? Understand, Archana? You type it and then you understand. See, do not look the entire code at once. Understand line by line. It should be more correct. Yes. Okay, good. And once you don't understand, go scroll up and understand what exactly this one. If you not understand, I'll do it again. Okay. Thanks. Bye.